And it'll be a drawing all by itself, or do it with on our architectural drawing. Since it's tied to a house, we're gonna do it this way, and then when we get civil engineering, we'll do it right. Okay, so we're gonna draw 7 and 8. I'm gonna start here on the northwest corner of lot 7. And we're gonna work in a clockwise fashion as we come around. Now, just so you know, when we hit these curves and stuff, we may have to jump around a little bit. That's good. But we're gonna kind of figure all this out together so that we can get this drawn. If we can't get some of it drawn, then we're gonna have to make a trip to the assessor's office and get a cleaner copy. That's just all there is to it. Okay. Now, the assessor will give you a copy of this based on that legal description we have written up here, and it'll cost you a dime. Okay, that's what they charge you per copy. Okay. But that's what they do. Okay. All right, so I'm gonna flip to the computer. The first 2 legs are fairly straightforward, and I've got them drawn right here. Tell you what, I'm going to use white as my main color here. Okay. So I'll just write the keystrokes on these. So here's the first point. We'll call it our POV. This line is at 295.05 feet at an angle north 55E.
Is it 0.05? Mine says 0.00.
295.06 actually.
0.06?
0.06. Yep.
Yeah.
35 degrees, 42 minutes, 29 seconds. That's to the east. This guy.
South.
Can you give me the rest of that?
35D, 28 minutes, 25 seconds east.
That's that leg.
Okay, and that's what we got. And the next one, next.
Okay, so I'll give you just a minute to get those 2 drawn in.
I have a quick question.
Yes.
So after we draw for our curves, after we draw our chord and everything and do our 2 circles and get our midpoint, and we draw that other circle, will they match up with those endpoints for that chord?
Should match up right on. Until you get to the last segment, because the polygon probably won't close on itself. The last segment, if it's on a curve, probably won't match.
Okay. So if it's,
I'll go ahead and do that just in
Yeah.
1 second.
okay.
Just if you got any questions. It should be perfect for this segment.
So does it necessarily matter where you start when you're drawing these?
Not really.
Okay.
No. And I like that because the long curve we draw on this is 180 degrees out of whack. And so you're going to see how we handle that. If you need more time, raise your hand. And I won't start yet. All right. If you need help, raise your hand.
So you use, so this right here runs parallel with this street, so you use that one right there. You use that south 36 degrees, 28 feet, and 25.
I'm glad it means it's
Yeah,
not
sure.
that road there, it's not really there.
Good choice.
Oh Why is it that, why they say unplatted on roads in that
Which
piece
road?
here? Both roads, on 4300 north and 2600 east, they both say unplatted.
Yeah, those are county roads,
Why would they be unplatted?
because they're not part of the plat. They're exerted out.
So only within that's why everything around
And the
them.
county owns them. Those are existing roads. Raise your hand if you need more time.
So this is in the real point of beginning for this whole section, is there? For this whole thing? That's why they said, look up in the right corner.
Yep.
It says real point of beginning.
POV, so you're on the corner of sections 23, 26, 24, and 25.
So that gives you this thing here.
Yep.
So I think it'd be fun to be outside all the time. No, it's cold. What do surveys do in the winter? They can't work, right?
Oh, yeah, they work in there.
How do you find these things if it's covered with snow? I mean, up there.
Metal detector.
What, really?
Yeah, the rebar around there.
And they're gonna go 3 feet down.
Where did you get the second one? Because we have our people here.
If the angle is not given, look for parallel lines. Okay, so it's gonna be parallel with that one or that one. So they're the same, see that?
Okay.
So that's your angle.
Okay.
Okay, sorry about that. If the angle is not given on the traverse length, start looking for parallel line segments that do have it labeled, usually a street center, something like that.
Something.
All right, Missy, you got one more leg yet to draw? Or are you good?
Yeah, I have those drawn.
Okay, Cheryl, you good?
I'm good.
Okay, all right, we're gonna move on. Okay, we come into a curve here, right? You notice that curve? What curve is it?
C7.
Yeah, it should be labeled right on there, C7. Now, I want to kind of bring you back, clear back to drafting 131. What do we need to draw a circle? We need the center and the radius, right? Okay, that's what we need. Center or diameter, one of the two, but we've got to get the center. Now, we know the circle passes through this point because the curve comes in. We also know all property lines, for the most part, and all roads, that it comes in a tangent condition. Okay, it comes in a tangent condition. Does that give us any clues on how to find a center? But yeah, any line perpendicular to a tangent line at the point of tangency must pass through the center. Additionally, when we do a curve table, they will give you the long chord, or the chord of the circle. Remember, on the chord of a circle, any line perpendicular to the chord at the midpoint must pass through the center. So we can use all of that, plus the fact that we now will know 2 points to find the center. That's really what we have to do. Okay, so first thing you're going to do, you hit on there and you see it's curve 7. So it's too much information to put on the drawing, so I turn the page and I find curve 7. Right here. Now, this is definitely not a standard curve table where whoever the surveyor was, he kind of made up his own headings. Okay, but what this is arc length. So this is the distance around the curve following the arc. Okay? This is the radius of the arc. You're going to need that one. For curve 7, it's 360 feet. Okay, so that's our radius. We'll need that. Delta is the angle turned by the tangent line and the arc and the chord. We call that our intersection angle. That's delta. Now, you don't need length or delta to draw this. What you need is these two. This first one is usually called LCB, for long chord bearing. This one's typically called chord. Okay? Now, this one, the chord, will be the length from one point to the next point on the circle, or the two end points of the arc. The bearing will be the angle of this line. So generally what we do is we draw the long chord using that information. That gives us 2 endpoints on the arc. From there, we can then solve for where the center is and use this to draw the arc. So that's what we're gonna do. Okay? So, I'm gonna go to the computer here, and let me show you how I'm gonna do it. Okay, so I'm gonna get on this end line. And I'm gonna do my line, you might have it, but I need to start my line first. And then I'm typing in that long chord information. So I say at, and on C7, it is 119.86 feet at an angle of north of 25, 53:26, 53 minutes, 26 seconds, and that goes to the west. And I get a line that shoots out like this. Okay, I love this. It's good. Okay, so to draw this line, here's your text. It is at 119.86 feet at an angle of north 2553 minutes 26 seconds west. Okay, there's your text. Is that the way the line was supposed to go?
No, I quit.
Did everybody get that drawing? Okay. It's 180 degrees out of whack. The line's right. This is that exact same case that you guys brought up earlier. Okay. So you got the line drawn okay. Now the line is correct, it just was recorded 180 degrees out of whack. So I'm just going to come in here and do the move command, move this thing from that endpoint to that endpoint.
Oh, that's easy enough.
If the line's correct, it's just 180 degrees out. Or you could rotate the line 180 degrees about it, whatever you want to do. Now, probably, did everybody get that moved in? Now I'm going to find the center. And you can find it due to the chord, due to the tangent. There was another method that worked just as well because we now know 2 endpoints. Okay. And maybe I ought to show you this so that you understand it. I'm going to come back to this guy and show you what you just drew. Okay, so use a pencil. What you just drew was a line or a chord that went right there. Okay? So you started on this point, and you drew the line at a bearing, and the other end of that line is this point. Okay? So now, we now need to draw that curve in. Okay? We all good on what we're doing here? Okay. So the quickest way, since I know 2 endpoints, is do a circle on one endpoint with a 360-foot radius. Go to the other endpoint, draw that same circle where those 2 intersect is the center, draw that, and you should have your arc. And it should go perfectly through those 2 points. Want me to do that one more time?
Please.
Okay. So here, let me change the color of this so you can see it. Go to this layer. Can you see that okay? There's my long chord. So I'm going to do a circle on one end of the long chord with a 360-foot radius. Go to the other end of the chord. Draw another circle with 360 feet. Where those 2 intersect has to be 360 feet away from both of those points. I come to that point, draw my arc back, and there it is, right there. That's the piece I need, right there.
Wait, do that last one, George.
Okay? Oh, undo. Delete that one. Go to where they intersect. Use that as your center point, draw it,
Oh, perfect.
and then you're just going to trim this up. Okay. I'm going to come down here and trim that side off, this side off, and that's what I wanted right there, that little arc.
By draw it, you mean another 360-degree
Yeah.
circle off the intersection?
Yep. And you end up with that. 360 feet are the circles.
I think so.
Yeah, you're doing 360 inches. It doesn't work.
Very good line. Do it again.
All right, let's go this way. If you want to take off now, you can. We're just going to shoot off. Let's finish drawing 7 all the way, and then we'll come back and tack on the 8. This one's given to you, right here. Is that 70, 10, 70 degrees?
That's what I'm running.
Yeah, it looks like it is.
10:58
Where?
west, and west.
10 minutes, 58 seconds.
I didn't mark
And then that is what?
that.
One more. Okay. So if you can't read that, let me put that up again. This segment is 2, 9, 5, 0.06 feet. Oh, wait, here comes the wrong one second.
You're at 306.58.
Yeah, that's between 6 and 7. So it's 306.5, that nice 5.
59. Is that 58 or 59?
South, 70 degrees,
I think mine says 5'9".
10
Oh,
minutes,
yeah, I do. Can't see.
58 seconds west. Okay, that's that one. Now we're into curve 16 at that point.
So you have to draw both lots individually?
Yeah. Well, you don't have to. You can just draw any line you want. So if you just read it off the information, you can go wherever you want. But ultimately, I want you to show both lots. Just one. Okay. So delete these two out for that. Yeah, just delete them. No, not this one. Don't delete that one. Yeah, delete all the other construction lines. That's a construction line. Delete that. And then just trim off. You want this piece here. Why are there 2 lines here?
I did,
Where's the property now? Where's the property line?
Is it 90 degrees?
So where's this line and this line?
oh, you're using this angle here. This angle here. Let me highlight.
Okay, so you have there, and there. Okay, delete this circle. I see what you got. Okay, so here's your long road. Zoom in on this a little bit.
Okay, for that angle.
Now draw a circle from
This
that
one's
end.
parallel with that one. For this one,
Give it a radius
so
360.
you're using, this is the angle. That's the name.
Come to that endpoint.
Using software.
You don't have to.
Remember that from Melanie.
No, my memory is too bad.
Yeah.
Doesn't work always.
That's the mark you want. Right here, and here, and everything else. Don't turn those on, just the arc. This one? Yep. Okay. Just leave the rest of those circles. Okay, so your property line is here, here, and then along that arc. Okay. All right, we all good? We're getting to your curve, Declan. This is the whole reason we're doing this. It's curve 16. Okay, we all good with this point?
I did the wrong line, yes.
Now, can anybody read what curve 16 says?
Yeah.
Can you?
Can you read the chart?
Yes.
Yeah. 105.34 feet, and you can't read that?
No, I can read curve 16. What curve? Oh, we were looking at curve 15, sorry. Yeah, so we can read 16.
16, yeah.
Okay, so let's put in the long chord of curve 16.
Okay.
And I've got 105.34 feet, is that correct?
That's what I got.
Okay, and then the bearing is north, 24 degrees, 25 minutes, 56 seconds.
West, yes,
Radius 275.
yes.
All right, let's draw that arc.
Okay.
We're drawing 15?
Now we're drawing curve 16.
Did we agree it's 105 or 106?
105. I got 105. Does anybody have a 106?
I got 105.
Okay.
Wrong way, over this way. Sure your input's right there.
Okay, mine kind of snapped right in there.
Yep. Does your angle go the other way?
Now look at your map, that'll tell you
Yeah,
which
I
way
got you.
the curve goes. All right, everybody get that? All right, this is line 10 right here, right? You've got both endpoints. You don't need to type it in, but I would recommend that you check it. Just draw the line, click on it. Properties is going to tell you what you got, and make sure it is the same length or within a portion of foot of what line 10 should be. So I'm just going to come on here, and I'm just going to draw this line from there to there. Then I'm going to use my property dialog box, click on it, and it tells me that this length is 42 feet 10 inches. So if I go to line 10, I find it's 42.92 feet. That's pretty darn close, because I'm 42 feet, almost 11 inches on that. Okay. And you could run that. I mean, take 10 or 11 and divide it by 12. What are you going to get? $11 divided by 12.
0.986.
Yeah, you're right there, right? You're within a decimal point of it.
So how long it should be?
I've got 42 feet, 10 and 15/16 inches.
I have 46 feet.
You have what?
46 feet.
You probably got a bus somewhere. You're off 4 feet, that's too far.
So if you did that bearing though, you're gonna have to go